to demonstrate how to set up these thiazolene forming reactions, and I'm going to demonstrate the proper use of sulfur containing compounds, bleach baths, and things of that nature. We'll be demonstrating how to use Lawson's reagent effectively. We're going to want to weigh the Lawson's reagent out into a closed microwave tube. So what we're going to do is we're going to take a beaker, microwave tube, and cap, and we're going to tare them. You can just simply stand up the microwave tube on the balance and place the cap on the side. That's absolutely fine. Close the doors and zero the balance. You can now put a note on the balance that says it's in use, and no one should use it for the time that you're going through this part. So we are going to set up a microwave tube underneath an inverted funnel. The inverted funnel is right here. It's connected to our nitrogen line, and I'm going to get a little bit of nitrogen flowing. Although this is not an ideal method, this gives us a little bit of a blanket of nitrogen over our microwave tube, and so that we can weigh out the Lawson's reagent directly into the tube and cap it kind of under this streaming flow of nitrogen. Make sure the nitrogen isn't too high or it'll blow the Lawson's reagent everywhere. Lawson's reagent is in this glass container. It is stored under nitrogen with parafilm. So the way that we store it under nitrogen is we just blow a stream of nitrogen into it and cap it very quickly. We'll kind of hold it at the nitrogen outlet over here. So what I need to do is remove the parafilm. And I'm going to open the bottle underneath my stream of nitrogen. I can now take up an inverted pipette, and we're just doing this to minimize waste, so we're not going to use a spatula or anything like that we'll have to clean. And I'm going to scoop out a bit of Lawson's reagent. And as you can see, I'm not shaking the pipette everywhere. I am just carefully twisting it in, and I think that should be good. I'll hold the Lawson's here while I cap it. And my smelly pipette can go directly into the bleach bath or the glass waste. So we'll just pop this in the bleach bath and we'll toss it out later. The nitrogen is still flowing, and I'm just going to place the microwave cap on this reaction. And now I want to carry it over in the same flask that I had tared earlier. Remember that we already have taken into account the cap, the tube, and this container. Our Lawson's reagent weighs 179 milligrams.
Hi, I'm Sarah. I'm going to be taking over the rest of the reaction for the microwave synthesis. Right now we have our Lawson's reagent back here. I'm going to be adding in a solid called benzoic acid. That's one of my starting materials. But benzoic acid is a solid, so I do have to open my cap under a blanket of nitrogen. And while the solid's inside the filter paper, I fold it in diagonally so I can pour it in easily without dropping any of the benzoic acid on the fume hood. And I cap it back on. We only use black needles, which are 22 gauge, because we don't want to make too many holes into this microwave cap. So we're going to go ahead and just add in. So I go ahead and purge my balloon 3 times. And once I have the balloon settle down and decrease in volume, that I can go ahead and start adding my other reagents. Now we've measured the appropriate amount of ethanolamine. We're going to go ahead and take out our purge needle, throw it in our container. And using a long 3-inch needle, we're going to go ahead and go to the bottom of our flask and try to pour in the ethanolamine directly into the lozenge reagent and also the benzoic acid and not to the sides. Now we're ready to go back to the microwave room. So I have our balloon and our flask, but also I'm carrying this jar right here that's specifically for our lozenge reagent synthesis. We're not going to put in our flask inside here until we come back because it smells really bad. So let's go to the microwave room.
This is the microwave reactor. We have a nice little hole here where the microwave tube fits into. Moving down, you can barely see the display, and it's an open vessel reaction that we're going to run, and it says fry thiazolene. If it does not say fry thiazolene and have these parameters, you should talk to your mentor. However, you really shouldn't be using the microwave without a mentor anyway. So there are various controls over here. This one changes the temperature. This one will change the time. This will set the maximum pressure. And up here we can set the microwave power. On the other side of the instrument, there's a keypad where you can enter in the appropriate numbers.
Now I'm ready to put my reaction in the microwave. So I just fit it into this hole right here. And so since we're keeping it open vessel, I don't need to worry about this. We're going to go ahead and press play. Right now we've set it to play. Sometimes what will happen is that there's too much ethanolamine. It'll start steaming up, just like it is right now, but don't worry.
Hear that rush of air? That's what you can expect when the instrument is cooling down.
Remember when we first started this reaction, our reaction was a white powdery substance. But now look, it's a yellow oil. And so we're going to move this into our jar. But the balloon won't fit inside the jar hole, so we're just going to open it under the fume hood and let out some air. Now we're back in lab. We set up our microwave tube back onto the clamp. We're going to go ahead and discard our needle and balloon. And there's a special container, especially for these lozenge reagents, specifically for these kind of ways. You can see that whatever is labeled like this is specifically for all our smelly reactions. So we're just going to go ahead, and since this one also contains plastic, we're just going to go ahead and take the top as well. And throw it all in there. We're going to throw away the balloon too, because it did have some steam from the reaction. We're going to go ahead and add in our DCM before we add in our stir bar. About 4 milliliters should do, just to dissolve the reaction. And we're going to go ahead and put in our stir bar and let it start spinning. Like your gloves are dirty throughout the process, maybe you got a little bit of lozenge reagent on your gloves, go ahead and just exchange them. Don't whip at them or take them on the hood. Just make sure you take them off first. Then you can go ahead and touch the container. We don't want to contaminate the container with the gloves. We're just going to push it in there. And close your glue tight again. And that's all. Yay! Now we're going to go ahead and do our workup. We're using 10% NaOH. This bottle is specifically for research only, and it's important that we use a clean pipette every time we extract from the 10% NaOH. We're going to do the extraction directly into the microwave tube. We're going to go ahead and stir it. turned off the stir bar machine or magnet. Since we use DCM, our organic layer should be on the bottom and our aqueous layer should be on the top. So I'm going to go ahead and take off the aqueous layer and put it into a Smarty aqueous jar. We're going to do this 2 more times. Now I'm on my last extraction. I showed you that I could use a stir bar to go ahead and stir my solution, my organic and aqueous layer, but like you've seen last year, you can also use a pipette and bulb to stir your reaction. Just mix it up and down, pipetting up and down as well, just to mix your reaction. We're almost done. I'm just going to show you how we discard our smelly aqueous. We usually dump all of this into the bleach bath, which is down here. So quickly, I'm just going to go ahead and pour all of this, including the pipette that we used. I'm completely submerge it in here. That's it. I'm going to go ahead and dry this with sodium sulfate. We're going to do that through a pipette and a little bit of cotton. And I'm going to put it into this 6-drum vial. I already tiered it, and I'm going to go ahead and concentrate it by rotary evaporator, and I'll purify it with washcloth. Thanks for watching.